My name is Ramoni Adeogun. I am an associate professor at Aalborg University in Denmark. I'm actually the technical manager of CENTRIC, and I also happen to also lead the third work package, which looks into the first layer of the wireless communication architecture and all that, right? Well, I think the CENTRIC project, from my perspective, is a very timely one. If you look at the history of how we actually make wireless communication share networks, it's all been that we make something that fits all, right? You have several applications, each of them having different requirements. They are meant to be used in different environment, but you just make one whole network, 5G, and then you expect that to actually meet all of them, right? What we have seen is that when you do this, you come down to a case where many of the applications are not actually met. With 5G, for example, we have actually promised ultra reliable networks with very low latency. Now we know that due to the rigid share structure of the share network, we cannot actually meet all of this, right? But how can we solve this problem here? And that is why CENTRIC actually comes in, and what we hope to do is to actually use advances in machine learning and artificial intelligence to evolve wireless communication share networks where we put requirement of each specific user as well as environmental requirement at the center point of the whole chain, right? So you start from that point, and what you want to do is to use an AI algorithm to actually evolve, based on this particular requirement, a network starting from the physical layer to the MAC layer and also RRM, right? And on top of that, CENTRIC actually also promises to look into mechanisms and frameworks for actually testing and benchmarking AI native interface. So at the heart of CENTRIC is what we call the AI notion, which basically means an artificial intelligence native AI interface, where you don't make specific handcrafted algorithms, but you allow the machine learning models to actually learn based on the specific requirement and actually evolve each stack of the wireless communication layer. Based on that, one key advantage of this is that you can now have a network that you are sure if you take it to another environment or you allow other users to actually try to use it, it can automatically adapt itself. Fantastic. I think I would like to start like this. I will start to actually tell you a bit about what Aalborg University brings to the whole work that we actually do, right? In work package 3, we have two main activities at Aalborg University. One is on joint communication and sensing, and the other is actually looking at transferability of neural network-based receivers which have been trained in specific environment or for specific users and all that, right? If we know that data is actually very costly, right? If we have been able to train in one environment, why do we need to spend so much to retrain again in another environment? So for this, we are looking for ways that we can now take something that was trained in a completely different environment or site, take it to another one, and try to actually optimize it with a very small amount of data set. I think this will actually bring very cool results, right? On the other track, on the joint communication aspect stuff, we are looking into how we actually evolve the reinforcement learning-based algorithm into a protocol such that you have something that we can call sensing for communication, where you can use the fact that you know there is a blockage somewhere to actually adapt how you actually transmit, or you could also say communication for sensing, where you aid detection of object and all that based on the communication share metrics and all that you actually get. And I think that actually brings me back to the last question on why do I think CENTRIC is actually important. I think for me, there is no better time to have a project which concentrates mainly on ML and AI for wireless communications. We have seen that AI has really actually achieved tremendous results in other fields, right? I believe in the next 10 years, when we actually expect the idea of 6G to actually start to materialize, we will realize that there are several unforeseen applications which needs more challenging requirement, and going in the standard heuristic approaches and all that will not really help us. We need something that can automatically actually adapt itself, and that you can only do if you have ML and AI in the loop.